An unloaded generator with a pre-fault voltage 1 per unit has the following sequence impedance Z0, Z1 and Z2. The neutral is grounded with a reactance of 0.05 per unit. The fault current in per unit for a single line to ground fault is. Now once they say it is a single line to ground fault, what you are going to do? First draw the sequence network. Okay. So what will you get? Internal voltage will be present and all of the impedances will be in series, right? So this is Z2, Z0 and also the fault impedance, 3 times of fault impedance, right? And also what will be the current flowing through this? This is IA1 is equal to IA2 is equal to IA0 and this is in turn equal to IF by 3 where IF is the fault current. Now we want the fault current in per unit. So you can see that all of the values here they are given in per unit only. Okay. So you don't have to worry. You can just use whatever values are given. So here Z0 we know, Z1 is known and Z2 is also known. What else is given? Neutral is grounded with a reactance of 0.05 per unit. That means this is the fault impedance. So this is, we can write this as ZF is equal to, it is given as reactance. So J 0.05 per unit. Okay. Now from the circuit you can get IA0, this is equal to EA divided by Z0 plus Z1 plus Z2 plus 3 ZF. Okay. So EA is given, the pre-fault voltage is given as 1. 1 divided by Z0 is given as J.15, Z1 and Z2 are equal plus 3 times ZF. So you are going to get J.15. Okay. So this will be IA0. Now IF is going to be what? 3 times IA0. Okay. So if you calculate this, then you are going to get 3.75 per unit. Okay. So we are only talking about the magnitude here. Okay, so this is the final answer. A 3-phase transmission line supplies delta connected load Z. The conductor C of the line develops an open circuit fault as shown in the figure. The currents in the line are as shown. Find positive sequence current component in line A. So here in this question you can see it is an open circuit fault. Okay. So whatever we discussed till now, they are short circuit faults, right? All of the lines are getting short circuited either with themselves or with the ground, right? Now here open circuit fault just means that if you can see phase C, the current is 0. That means there is a break somewhere in between. So let us say there is a break here, then there will be no current flowing. Okay. So that is the open conductor fault. Now here the question is, we have to find the positive sequence component in line A. Okay. So it is about sequence components. So we can use our relation. What is the relation? Currents, right? So we will take IS. So this is equal to A inverse IP. Okay. So because it is given as phase A only, there is no problem. You can write IA0, IA1 and IA2. This will be equal to 1 by 3 times 1 1 1 1 alpha alpha square 1 alpha square and alpha. Okay. And IP is IA, which is equal to 10 angle 0 degrees, IB is equal to 10 angle 180 degrees and IC, which is given as 0. Okay. Now we want the positive sequence component, that means IA1. Okay. So from the equation you can write IA1 will be what? 1 by 3 1 into IA plus alpha into IB plus alpha square into IC. Okay. This anyways it will become 0. So if you solve this, you are going to get 1 by 3 10 angle 0 degrees plus 1 angle 120 degrees into 10 angle 180 degrees. Okay. So the final answer you are going to get 5.77 angle minus 30 degrees amperes. The positive, negative and 0 sequence impedances of a 3-phase generator are Z1, Z2 and Z0 respectively. For a line-to-line fault with fault impedance ZF, the fault current is IF1 is equal to KIF, where IF is the fault current with zero fault impedance. The relation between ZF and K is. So we have various options here. Okay. So now this is a line-to-line fault. So you have to draw the corresponding sequence network. So what will this be? This is the internal voltage. Here you will have the positive sequence impedance, and here you will have the fault impedance ZF, and finally the negative sequence impedance. Here there will be no zero sequence network, right? And what is the current flowing through this? IA1. If you want to take it as IA2, it is going to be minus IA2. Okay. Now what is the fault current? Fault current, it is going to be root 3 times IA1. Okay. Now what is given? When there is a fault impedance, then the fault current is IF1. So what will this be? Root 3 times IA1 you can write as EA divided by Z1 plus Z2 plus ZF. Okay. What about when ZF is 0? Then fault current is IF, and this is equal to root 3 EA divided by Z1 plus Z2, because ZF is 0 here. Now what we want? We want the relationship between ZF and K. What is K here? It is given that IF1 is equal to K times IF, right? It is given here in the question. IF1 is K into IF. So here you are going to get root 3 EA divided by Z1 plus Z2 plus ZF. This is equal to K root 3 EA divided by Z1 plus Z2. Since all of the options they are given in terms of ZF is equal to, right? So we will try to get ZF on one side, right? So this you are going to get Z1 plus Z2 is equal to KZ1 plus Z2 plus KZF. Okay. So from here ZF you are going to get as Z1 plus Z2 minus KZ1 plus Z2 divided by K. Okay. So final answer is going to be Z1 plus Z2 into 1 minus K divided by K. Okay. So what is the option here? This is option A. Okay.